Okay, now let us continue with this second part. The second part now, or the first part is saying that let us find the derivative with respect to x of this function, right? Of function y, where y equals this. Now, to find it, we simply gonna find it. This one now we just having y equals to a function u on a function v, and to find the derivative of this y prime, which is equals to what? It will be v bottom the top, bottom derivative of top minus top derivative of bottom dividing by bottom all squared. That is bottom the top minus top the bottom dividing by bottom all squared. So we are just having that it will be v u prime minus u v prime all on v squared. So this is the formula that we need in this part. We call it the quotient rule. Quotient rule. These are some of the techniques of differentiation. Now, our u will be equal to ln of 1 minus x squared. Now we need our u prime as well. So our u prime will be simply be equals to, well, if you have to find the derivative of a logarithmic function, it is simply the derivative of that function, of what is inside the function, dividing by that what is inside the function. That is just the derivative. So the derivative of this, so now we are having the derivative with respect to x of 1 minus x squared all on 1 minus x squared. That is just the meaning. So now we find the derivative of that. Now the derivative of constant is 0, and the derivative of negative 2 will just be negative 2, will just be negative 2x. That is, you bring down the power down, negative, bring down the power 2, they subtract it by 1, 2 minus 1 is 1. So you get negative 2 on 1 minus x squared. So this is our u prime. Now our u prime equals this. You can even box it. Our u prime equals that. Now we go ahead now to find our v. Our v is equal to e to the negative 2x. Oops. Our v will be equal to e to the negative 2x. Now to find the derivative, so I'll just do same thing like the chain rule. I'll say let u equals to negative 2x, then du on dx will be equal to negative 2. Correct. So the derivative of negative 2 is just negative 2. Now our v will now be equal to e to the u, and our dv on du will now be simply equal to e to the u. If you differentiate e to the something, you just get that. Are we there? Now we come to find our dv on dx will now be equals to, we had our dv on du times du on dx. You see they have changed it up. It's just like this one can cancel the du. It's as if it can cancel, right? We have it like that. And if you substitute, we have dv dx, dv du is simply e to the u multiplied by du dx, which is what? Negative 2. And we started with x, so we have to end with x. So you substitute, your u is what? We said u to be equals to negative 2x. So it will be e to the negative 2x times negative 2, which also gives you negative 2 e to the negative 2x. So this is our v prime, or dv dx. We box it. So now to find, we already now know all to substitute. We just substitute in our v u prime minus our u v prime all on v squared, which will now be having our v is simply e to the negative 2x. So e to the negative 2x, and our u prime is simply what we boxed here. We are negative 2x on 1 minus x squared, negative 2x on 1 minus x squared, minus our u. Our u is simply equals to the ln of 1 minus x squared minus the ln of 1 minus x squared, ln of 1 minus x squared, multiplying by v prime, and our v prime is simply negative this negative 2 e to the negative 2x. All that we divide our bottom square, that is v square, which is negative e to the negative 2x, all that squared. And you end here. Please don't go ahead and be saying that you want to simplify. They did not ask you to simplify. If you have to simplify, many things can cancel, but they did not ask you. So this is your first derivative of that function. Your derivative of y with respect to x. So this is the result. Or if you like, you can go ahead and factor e to the negative 2x into, that is, we are having here, we are having it here. So we'll be having, or we can even factor up there is negative 2e to the negative 2x. So we'll be having, what will be left here with x on 1 minus x squared, 1 minus x squared minus the ln of 1 minus x squared. All that is being divided by, e to the negative 2x. All squared means times e to the negative 2x, two of them. And you see that one of your e to the negative 2x will cancel with the one outside here. One here will cancel with one here. And you just get negative 2 all into x minus ln of 1 minus x squared. Don't forget to divide this by 1 minus x squared. All that is being divided by e to the negative 2x. So this is your final result, or to write it well, you can just put our e to the negative 2x outside here. And this is simply your first derivative, so you can write here y prime or dy dx. So these are one of the techniques that you can use to do the differentiation, and you can use the rules interchangeably. You can call your quotient rule to be product rule, and you still apply it gently by, maybe if I'm having the derivative, or let me say I'm having the derivative of 2x, I can call it to be 2x over 1, and I apply my quotient rule here. It will still work. If I can still call 2x to be 2 as my u, and then x to be my v. I apply my product rule, it will still work. So take your time. The technique you are using is always good if you know it. And thanks for watching. You can like the video, you can subscribe to our channel, and thanks for watching, and have a great day.